everybody. Thank you for joining. And we'll be starting the webinar in a few minutes. Okay, Jitendra, do you want to open the session for today? I suggest that we can get started.
Yeah, shall we start?
Jitendra, would you like to open the floor, or would you
Yeah.
want me to do
Okay.
to start?
I thought my mic was on mute. Okay, I'm starting. Thank you. Hello everyone. I'm Jitendra Pradhan, a technical support engineer at Ramkarsis Private Limited. I'm dealing with the sales and providing the technical support for Fluxys and other geotechnical products that we are dealing with. So here in this webinar, we'll see how Daarwin can be very helpful for our geotechnical projects that we are conducting in daily lives. Okay. So Daarwin is the first cloud-based platform developed by a Spain-based organization, SAALG GEOMECHANICS, to connect and to centralize the geotechnical data over the whole project life cycle. Yeah. And this Daarwin platform can help the end users to correlate the design models, their numerical models actually, with the real-time data analysis that they are dealing with in a parallel high-performance cloud computing solution to perform the sensitivity analysis, deck analysis, etc. In a combined technology with the Fluxys finite element numerical solution to figure out the various geotechnical uncertainties, then they can actually optimize the construction processes that they are dealing with, and also they can reduce the execution time and the project cost also. And again, it also represents like one innovative solution, you can say, for managing all the geotechnical data. They can store actually their site borehole things and centralize and digitize it. And it can be your CPD data or your geometric data or inclined data or anything. And later on, if you want, you can actually able to retrieve those things, and also you can share it with accuracy. And today from SAALG, we are here with water mixing. He has a background in technology, innovation, geotech data, and bringing new products and solutions to the market. He is the new business manager at SAALG GEOMECHANICS, and he supports the partners and clients in adopting new technologies and ways of working, and that includes the advanced Daarwin's geotechnical platform. Over to you.
Perfect.
Wada.
Thank you very much for that introduction, Jitendra, and also thank you everybody for joining today. I'm very pleased to be presenting for all of you today. And before I start, I would also briefly like to mention something on our partnership with Ramkarsis, our esteemed partner. They have an expertise on tech software, many years of experience there, and they have a great reputation and local knowledge in various regions, such as India, the Middle East, and Southeast Asia. And that also brings me to the reason why we're organizing our webinar today, connecting to people in the construction industry and the geotechnical industry in those areas, India, the Middle East, and Southeast Asia. There's also people joining from outside those regions. They're also very welcome. But the meeting content for today is tailored for those regions. At the end of the session, we have room for questions, and I'm curious to hear your questions. So please feel free to share them. You can already drop them in the Q&A box of our meeting, and then we'll get back to them later. So if throughout the meeting, throughout the presentation, you have any question, feel free to drop your question there. And you'll also receive the slides by the end of the webinar. So you will receive the information. Okay, so today I will be sharing a story with you about Daarwin, our state-of-the-art geotechnical data and analysis platform. And what Daarwin does is that it analyzes data in advanced ways, and as such is able to reduce the geotechnical uncertainty on a project and on an entire life cycle of an asset. Now, before we continue, let's start at the very beginning, because why should we care about geotechnical uncertainty in the first place? So what you can see here is some of the landmark projects that we have in the region. So some are already completed, others are currently being constructed, and others are only in the planning phase. For example, some examples in India, such as the new airport in Mumbai, the Trans-Harbour Link, the Palm Islands in Dubai, the Peruri 88, a landmark icon in Jakarta, Indonesia, and Capita Spring, another skyscraper in Singapore. So let's take a closer look at the size of the construction markets in some of these countries. What we see is that the market in, I see that somebody has problem with seeing the screen. If more people have, let's take a look at that. I believe everybody can see the screen. If not, please feel free to let us know. So what we see is that the construction markets in India, Singapore, Indonesia, UAE, and Saudi Arabia in 2023 is already significant. However, if we look one decade further, what we see is two things. Not only do they show steady growth, but in some cases, such as Indonesia and India, we see that the markets are really expected to double or nearly double in only 10 years. So that's really massive. All of these projects, they have something in common, and that is the geotechnical uncertainty. So with that, we mean not knowing the geological composition of the soil or the physical behavior and the effect that that will have on the structures that we will build upon them. So to some extent, whenever we're dealing with these type of projects, we have a bit of a black box situation at hand. And our deal as geotechnical experts is to deal with that uncertainty to the best way of our abilities. Now, this uncertainty, it creates really tangible problems for us. And I will explain to you so in three ways. And here you see some numbers or variables, and I invite you to think about what they represent. So the first one, it represents overdimension, and it was an X percentage, because often we don't know how much we have to overdesign or how much we do overdesign. Now, why is overdimensioning a problem? Simply, it happens because we don't know how the ground behaves, so we come up with a conservative design, and that obviously requires extra materials, extra time, and for the end client, that means that they ultimately will pay too much for the construction that they have. For the others involved, such as designers and contractors, it's also a problem, because we have to come up with an overdimensioned design, not because we want to, but because we cannot rely on the right, good quality data to make a more efficient design. So just imagine what we could win if we reduce the overdesign, if we would need less material, if we could design and construct faster, and overall cheaper for all of the parties involved in the industry. Now, the second part represents the delays or the malfunctions that we can encounter on our project. The construction industry has a poor track record of delivering on delivering projects on budget and on cost. 9 out of 10 projects experience cost overruns, and 40% of the cases are directly related to a lack of understanding of ground behavior. So this tells us that tackling the problem of understanding really our ground behavior is directly related to creating the impact on the entire project. And the last number, 60,000, unfortunately, it's a serious number and one that we should keep in mind every day. According to the International Labour Organization, ILO, a United Nations agency, they estimate that per year about 60,000 people die due to accidents in the construction industry. It's people who don't come home at night to their families and their loved ones. And we know that unknown ground behavior can have a serious effect in terms of failure on projects that may endanger life and property. So these are really tangible ways that we see that geotechnical uncertainty has these far-reaching effects in our industries. Traditionally, we see that the industry tries to tackle it in various ways, typically in 3 stages. So in the first stage, ground investigation by getting more borehole and CPT data. In the second phase, numerical modeling tools, a phase that many of us love, right? We can put various scenarios in here. We can model different scenarios, different complex geometries and physical behaviors. And the last one is the monitoring on projects, if it's used. However, if we take a picture of an entire life cycle or an entire project cycle, we're still seeing that we start a project with limited or poor information. And even though we're measuring a lot, we're not enriching the data for our models. So often what happens is that we use this data to compare to some kind of threshold, but there's really a disconnect between these phases and nobody's actively integrating this data. So you can say that geotechnical uncertainty is not only a problem for those people in the industry, but actually, ultimately, as a society, we all pay a price for this. So what we propose at SAALG Geomechanics is to connect and analyze this geotechnical information to better design and predict the ground information. So what we do there is to use conventional and historical data as well as monitoring data, if available, throughout the entire project. Now that delivers concrete and tangible benefits for our clients. Apart from the reduced geotechnical uncertainty, we see that clients can digitalize their entire project. They have tools that allow them to design better and to design faster. It helps people to stay in control of their project, to deliver on time and on budget. Once it's moving into the construction phase or the operational phase, you can detect instabilities in advance. And throughout the entire project, you can design and operate with more safety on your project. So how does Daarwin do that? Well, if I reduce Daarwin to its core essence, really what it does is that it reduces risk and it increases the insight that we have all along the entire asset lifecycle or project lifecycle. What Daarwin then does is at key critical points, it delivers tools that are useful for us, designers, engineers, contractors, asset owners in the project involved. So the first phase, the planning phase, is where we provide insight into your location. We help you to understand the ground conditions, understand the assets. And what we do here is that you can organize all of your private data and look for public data near your project. Today, we have more than 6 million public boreholes disclosed in our database, and I'll mention something about that later as well in a brief demo that I'll demonstrate. In the design phase, we give designers and engineers really state-of-the-art tools to come up with the design in only a fraction of the time. And for this, we do something that I'd like to highlight. As you see listed at the bottom, we can calculate about 400 numerical models in Plaxis in less than 30 minutes. And I'm sure that you know how long it could take to analyze one single model, right? It can take hours, sometimes even days. So imagine what it would take if you would calculate 400. The reason why we're able to deliver so quickly is because of our cloud computing infrastructure. We have 200 cloud servers with 200 Pluxit licenses stacked in parallel. So this is as sudden as if suddenly you have 200 colleagues who help you in your work on a very specific task. The back analysis, that's a part that we use in the construction and operations phase. This helps us to improve the original design, either in the design phase or during the construction. What we do here, the back analysis is based on the observational method with genetic machine learning algorithms. And what it really is it's a tool that we usually didn't have in the industry because it was simply too time consuming. Now suddenly we do, because we have 5,000 models that we can analyze in 8 hours. And sometimes this would take, normally it would take up to weeks or months. And now you only need 8 hours for that. Also in the maintenance phase, you can continue monitoring your asset and as such, keep in control of your project. So who are we? I've talked about geotechnical uncertainty. I've talked about Daarwin. Who are we? Who's SAALG Geomechanics? Well, SAALG Geomechanics is one. Maybe I'm gonna pause quickly here. I see some people cannot see the screen.
Yes. Yeah. Could you reset the screen water again?
Yeah, I can share it again. I do understand that some people do see the screen, right? So I guess it's only a few people who
Yes.
who have this problem. But we can think of a workaround. I'll share in a different way that usually is more feel safe, let's say. And what I'll do is share this window. And I believe right now everybody should see the screen again.
Yes, the screen is visible.
Yeah, do you see it again? Okay, good.
Yeah, yes, now it is working.
Good. Then I will jump directly to where we left off.
Yes.
Okay. So again, for those who couldn't see the first couple of slides, no worries. We will share this, the slides with you and also the recordings. I'm sure there they will appear. So apologies for those who couldn't see the first part. Good. So who are we? Who's SAALG Geomechanics? Well, SAALG Geomechanics is really a combination of 3 expertises: geotechnical expertise, data analytics, and software development. You also see that in the profiles that we have on our team. So these are some of the profiles that we have. Christian dos Santos and Ignacy, they are the founders of SAALG Geomechanics. You also see it in other people who we have on our team. For instance, Paddy as a data scientist developer and an expert on AI. And Irene, also one of our innovation team leaders with a PhD in geomechanics. So we are lucky to share this slide, and we're very happy to share this slide because this really shows the clients that are joining us on this journey. Typically, we deliver value for the entire industry, but our typical clients that we directly work for are these 3 categories: engineering firms, contractors, and asset owners. And I'm sure you see some familiar names in here. For instance, among the engineering firms, Mott MacDonald, WSP, COE, and AECOM. Very active in India as well. Kajima, also one of the cases, Sistra and Balfour Beatty. And some esteemed asset owners like Deutsche Bahn and the London Organization for Transport. You also see this reflected in the projects that we currently have. You see that the projects in Europe, the Americas, and Australia, New Zealand, they're already well represented. What we want today, and that's also the reason for this webinar, is that these tools also reach the industry, the markets that we are talking about today: India, the Middle East, and Southeast Asia. And we're active not only in the construction. So we can say that we're proud of the tools that we deliver. But ultimately, we hope that our clients are also happy with what we do. What we see here is that people like people in McDonald and Kojima, they give us great feedback, and we're really happy to share that with you. Great. So what I would like to do is now show you a brief demo about Daarwin. And for this, I'll move over to this part where I'll start the following demo. So Daarwin is accessible through any standard web browser. You can access it right now yourself as well. And what you'll see is that you have two options, the private workspace and at the bottom, the public workspace that I'll enter right now. In here, we have 6 million public boreholes disclosed. As you see, most of them in Europe, the Americas, and Australia. If there would be a public database in your area, we can disclose it here as well. And then your area might look similar to this. In this case, I'm zooming in at Barcelona, where our office is located. And you see the ground information points arise. And what you can do is you can view this in more detail. And you can see if this is something that's of interest to you. And if so, you can, for instance, view the source information or download it for your own use. So again, you don't need any license for this. You don't need any account for this. You can already access this nowadays, perhaps if you have a project in one of those regions that I mentioned. Now let's enter the private workspace. That's a completely different story. That's a completely protected environment where you can only access with your credentials. And even the SAALG employees, we don't necessarily see your project, and we don't use your data in any way. Now I'm quickly going to the mapping environment because I want to continue the story about the data that we use on our project. What you see here on the right is boreholes. You see the data in your area that is available. So what you can do if you want to get this data on your project is you have different options. You can do it manually through AGS or through PDF. And the PDF can either be a digital file or it can be a scanned version. What you need to do is select the language. You select the file that you want to digitalize. Obviously, this can also be an entire database. And you select the coordinate projection. And just to give you an idea of what that looks like, this is what you would, a typical file that you could digitalize and that we will show for you right now. Now, once you click digitalize, the AI-powered engine and algorithms start to run. And it takes about 40 seconds per page to digitalize this into a digital format. And I already prepared this before, so I can show you what that then looks like. And as you see here on the screen, you have all the information available that you would expect. Geological data, sample information, lab tests, in situ tests, ready for you to use on your project. You can also export this data again to use it elsewhere on your project or elsewhere in your workflow. As far as we know, we're the only company worldwide that offers this service with AI-powered algorithms in real time. Now, once you have your data available, you can take a look at the ground model and you see your project environment. So there's two projects here, the green one and the red one, and all of your data points available. You can analyze this further. For instance, if you go to units, you see the different ground layers that you as a user have identified. And let's take a closer look at our clay layer. What you see here is the different layers and all of the layers that contain some kind of clay in them. And you can analyze this further by hovering over the points, and that will provide you extra information. Apart from that, you can do specific geotechnical analyses. So for instance, if you want to know the plasticity, you can look at your Casa Grande plot, but also any other, let's say, industry type plot, you can find it here. And if it's not there yet, we can develop it for you because all of this is developed in-house. Now, if we take a look at the cross sections, for instance, you want to make a geotechnical profile, you can do so right here. For instance, let's take a look at profile number 2, and let's take a look at the unit geometry, where we'll be seeing what that profile looks like. As I said, in a very early stage, you will have high-level information that helps you to better understand the ground and the models that you're working with. Now, apart from the geotechnical information, we also work with instrumentation data. So you can disclose here your monitoring devices, for instance. What you see right here is an inclinometer installed, and currently we can take a look what it's doing. So we see that it is plotting information about the displacement at this specific location, and it's giving that information every 24 hours. What you can do then is that you say, I want to know with certain thresholds, if it exceeds a certain value, that a trigger is set, or I get a notification, or I'm being warned. Okay, so this was the part about the mapping environment. Now let's go to the first module part, and I just quickly want to show this to you because this is the part where you would upload your model, your Fluxus model, and in this case for the demo we'll be covering a 2D example, a typical D-wall excavation site with temporary props. Sure that you're familiar with that, and it's also compatible with 3D. So we're compatible with all versions from Fluxus from 2016 onwards. I will skip a few steps here, and I'll directly go to a part that I think is of interest to you, and that's the last two items, the run and the results part. First of all, the sensitivity analysis is the tool that in the design phase helps you to understand what are the parameters that I need to optimize and how should I optimize them. As soon as you select your model, you have all of the information that you have in your Plexus model, you have it available here as well. So you set the search space that you want to analyze, and step by step you add the parameters as I just did. You can also add secondary effects such as bonds, constraints, phase parameters, the more technical information. I'll be skipping that for now for the time that we have. Once you click on Run, this button at the bottom right, you will activate those 200 virtual machines with 200 Plexus licenses that are all ready and available for you to deliver these results. So let's quickly go to the results tab then and see what has happened, because we prepared this for you already. And in this case, you see that it took us 19 minutes to calculate this. What did it do in that 19 minutes? Well, it analyzed 176 Plexus models. So what we can do, I'll quickly show you what you can do with that information. You can analyze that information. For instance, if you say in one of my construction phases, I want to understand more about a specific soil layer with its different parameters. Let's say we select one of the walls that we have available. Remember, it's a D-wall excavation site. And right here, you can then analyze all the moments, the shear stresses, actual forces, and displacements. One tool that we developed and that many clients give very positive feedback about is the sensitivity index, which I'll also show you. The sensitivity index, what it does is it helps you to understand what parameters are of largest influence in my entire project. So right now I'm selecting all of the parameters in my project and all of the model phases, all of the construction phases or excavation phases, and I group them by model phase. Now let's analyze, for instance, the inclinometer at 80 meters, because at that point, let's say in the previous step, we saw that there was a large horizontal displacement. With the sensitivity index, you directly have an understanding about the influence that each of those parameters have, not only on the entire project, but also on the specific excavation phases. So right here, you see of each of those excavation phases, what that parameter exactly does and how it behaves. And what it does is it helps you to understand, if I want to optimize the design, what parameter should I be looking at? Obviously, you should look at the parameters with the largest influence there. Also, let's take a quick look at the back analysis. In this case, it took 6.5 hours to analyze, much more than the 19 minutes of the sensitivity analysis. And that is because it's a more complex model. So in this case, it took us, or what we did is we analyzed more than 5,000 models, 5,700 models. And I'll also quickly walk you through that. And now I'm going quickly through this. If you would be interested to dive into this in more detail, we can always do so in a separate meeting. Now, in this case, I'm going to select 2 construction phases. And again, I'm going to look at my inclinometer, and I'll compare my monitoring data to my design data. And what you then see is the following. The orange lines are excavation phase 1. The purple lines are excavation phase 6. The dotted lines are your design values. and the straight lines are the data that's coming off of your monitoring devices. So you see that the displacement between the design and the actual situation is it's quite different. There's a discrepancy there. So what happens if we plot in the optimal value from the back analysis? Well, then directly you get an optimized value and an optimized plot from what that information could or should look like. You already see that trend happening in your first excavation phase. So if you tackle this problem in your first phase, you would be able to have the benefits later in your phase as well. One last remark here. Right now I worked with monitoring data, but you don't need to work with monitoring data. You can also use, let's say, design criteria instead. For instance, if an asset owner says, I need a maximum displacement of 10 millimeters, you can add that as a design criteria here on your model. Good. Then I want to move to the next part. This was a demo, lots of information, I suppose. And what I want to do next is to make it more tangible for you. How does that work in real life? Well, what I said before, we can deliver value to anybody involved in the construction and geotechnical industry. And here again, you see our main client types: engineering firms and consultants, contractors, and asset owners. So in the first place, we are reducing the geotechnical uncertainty. That's a benefit for everybody. We're also helping with project control to keep the project under control and maintain the budget and planning to the schedule. You can design and operate with more safety, and you have access to more data and better analyses, as well as helping you to reduce over-design and in such helping you to save time, money, and material. Ultimately, we're also helping to optimize the staff and thereby also saving money down the line. Now, for today, for the last part of today, I would like to take a look at two concrete examples, two case studies about how Daarwin works in real life. And what you see here is the two case studies that I've prepared for you, one in the UK and one in Dubai. So the first one in the UK, here we were involved in the HS2 project, the highway high-speed railway project, one of the largest projects in Europe at the time. And for context, you see that we were involved with one of the stations in Birmingham. Now, in this case, it's a situation relatively similar to the demo that I showed you of Fluxus, a D-wall excavation with temporary props in between, and also inclinometers were installed. What happened is that we built this model in Daarwin, and just for context, here you see a cross-section model. And we worked with a consortium of the asset owner, HS2, Balfour Beatty and Vinci as the contractors, and Martin McDonald as the designer. They came up with an original design, and the original design was based on the following data. This is information that you see from Daarwin. And what happened during the excavation phase is that we saw that actually, from a geotechnical perspective, the situation was more beneficial than anticipated. That means that the mass strength revealed during the excavation was higher, and the mudstone was less fractured. And what that basically means is that the soil conditions were more optimal, they were stronger than we anticipated for in the original design. Now, thanks to the back analysis capability that we had in Daarwin, we were able to improve the model prediction to a more realistic situation. What that had as a concrete result and a concrete outcome is that one of the temporary props that we designed for was not needed anymore. And you can imagine that delivers concrete benefits in terms of time, material, and money spent for everybody in that project. So in the end, we could call this project a great success. Not only us, but also our clients. Here you see some of the screenshots that, for instance, the asset owner reports on this, that the designer reports on this, about how they innovate through using Daarwin. And if you make it really concrete, only with our involvement in this specific part of the project, this specific station, we were able to reduce the program with 1 month. We were able to deliver a cost saving of £300,000 and reduce the carbon emission footprint because of the material that we didn't use because of that temporary prop that was not needed to construct. Let's take a look at our second case study. I think for many people today closer to home, the Paramount Towers in Dubai. I'm sure that many of you have seen this. It's a complex consisting of 4 towers of 270 meters tall. And for the foundation, you need 600 piles. Now, in this, we work together with Dr. Marwan, whom perhaps some of you know as well, from the Dubai Development Authority. And what we did was that we did 2 static pile load tests in Daarwin. The analysis and BackAnalysis for this. So here you see some of the screenshots that we used in Daarwin. And moving fast forward, what were the concrete outcomes? Well, the concrete outcomes were, again, quite significant. What we were able to conclude is that the soil conditions were more optimal, and therefore the pile length that we designed for could have been reduced with an average length of what we analyzed of more than 60%. So just imagine what this would happen if this would be the case for the entire 600 pile foundation. If you can reduce your foundation with more than 60%, if you can reduce all of that construction time, if you can reduce all of that material, and if you can ultimately save that loss on your project. So these are concrete examples, but what is next? What is on the horizon? Well, there's 3 things that I would like to highlight. The first one is that in Daarwin, we're continuously developing new functionalities. So among others, about ground interpretation. What we'll do is we work towards a 2D and 3D ground interpretation, or in other words, ground modeling capability that will be available for you as well. You can also update your models in Plexus with the ground information present in Daarwin. And what you can do, and one of the functionalities under development, is to extract geotechnical parameters within the information that you have in Daarwin and export that to your Plexus model. So furthermore, you can export a model with the geometry of the ground model and the parameters that you defined in Daarwin and assign to the soils in Plexus. Now, today we only covered the construction industry, really, but Daarwin is expanding to new markets as well. And as you can see, we are developing solutions for the tunneling market. What we do here is that we analyze geotechnical data in real time, and we improve the advanced prediction and help the project team and the operators involved to construct in the most effective manner. And if you're interested to know more about this, I invite you to reach out to us. Also for mining, we have several solutions, for instance, solutions for your tailings. And again, if you are interested in this, please contact us and we'll be happy to tell you more. And that brings me to the end of my presentation today. Before I close off, I would like to once again thank our partner Ramkatsis, and in particular Meda and Jitendra in their support for organizing today's webinar. And if you would like to contact us, you can see our email addresses provided at the slide, and you can scan the QR code as well if you would like to book a meeting with me directly. I want to again thank you all for participating today, and I suggest we open the floor and see if anybody has any questions for us.
Thank you, Otto, for the informative sessions. Participants, if you would like to ask anything, you can just unmute your mic, or you can mention there in the Q&A section also.
So I see one question maybe coming up from Amir Alipur, or actually a few questions, questions already.
Yes.
Should I say something about it? So somebody asks about the basically the service fees and the pricing structure. Let's start with that one. So I can show you actually a slide. If you allow me to switch my screen quickly, I can show you a slide real quick about our pricing structure. So here you see our Daarwin plans, and how Daarwin works is that it consists of a subscription model for which you have access to all of the functionalities that I just showed. We work with a standard plan and a standard plus plan, and that has different number of users, projects, models, and instruments capable to integrate with your project, and that depends on the situation that you need. Now for that, you pay 150 euros per month or 350 euros per month for 5 or 15 users. then our concept and our philosophy is that you only pay for what you use. So if you never use a sensitivity run, you're not going to pay for that. If you never use a back analysis run, you won't pay for it. To give you an idea, here you see the prices for the sensitivity runs and the back analysis run. With your Daarwin subscription, you have access to these. So whenever you want to access it, you can run these analyses, and you pay 90 euro per hour per run for sensitivity and 100 euro per hour per run for back analysis. And to make that more concrete, I showed you the demo, 19 minutes sensitivity run. So that would be approximately 30 euros. And 6.5 hours back analysis run, that would be 650 euros that you use for that specific task, for that specific analysis. And after you have those results, you can continue your work as such. And the reason that we're able to offer that is that we have that cloud infrastructure with 200 virtual machines stacked in parallel with 200 licenses. I'll also briefly show you the digitalization pricing. What we do here is that you pay per page. And basically, the more pages that you have, the less that you pay. If you really have entire databases with a specific format of over 5,000 boreholes, then we have to define how it works. But typically, you pay 3, 2, or 1 euro per page digitalized. What you see is that the first part, I'll briefly explain how the pricing works. The first part, written in italic, that's your Daarwin subscription. So there's some clients that say, actually, I'm only interested in the digitalization part, sensitivity and back analysis runs. I'm not going to do. That's okay. Then you only pay a small part for your Daarwin subscription, and then the second part is the price per page that you would pay. So 3 euro and 500 pages makes up for 1,500 euros. So that's roughly how it works. I think that's probably enough information for now. And that is so that's the pricing structure that we use here. Good. Oh, I stopped sharing my screen. Let's see if there's any other questions.
He has also mentioned another 2 questions, like for back analysis, may I know which software license you want? Fluxys 2D, 3D, Flux, Light, etc.
Yeah, so that's a really relevant question as well. I can imagine that you have that question. I'm gonna bring up this screen again just so you have it present. The setup that we work with is with Plexus licenses. So it has Plexus 2D and Plexus 3D, and that is, let's say, the integration that we have with Daarwin. Now, let's say that you're in a situation that you actually work with another type of software. Then what we can do is we suggest that you reach out to us and that you explain the situation, and we look at the model, and we see if we can set up a model or set up a solution that allows you to make use of the functionalities that we have in Daarwin, even though that you're not necessarily using Pluxus on your day-to-day workflow. So even if you don't use Pluxus, we always recommend that you reach out. But coming back to the core of your question, yeah, the main software licenses that Daarwin is compatible with is Plexus 2D and Plexus 3D. And I can also show that maybe in a workflow slide. So here, for instance, because you asked about the back analysis, what you do is that in the first step, you upload your Pluxus model. And it's important to mention that as soon as you upload your model, you can liberate that license. So you can use it for whatever task that you want to use it for. In Daarwin, we don't need it anymore. We only need it at one single point to upload your model. So I think that's important to keep in mind and important to highlight. Then in Daarwin, similar to the demo that I did, you set let's say, the analysis that you want to analyze. You optionally combine it with instrumentation data, and that is the part that you send to the 200 virtual machines. And then you get the results as we discovered in the demo as well. So again, this is one of the reasons why we're able to deliver the results so quickly. 5,000 models in 8 hours is really an impressive performance.
He's having another question. Would it be possible to use Daarwin for reliability analysis like Monte Carlo analysis?
So the reliability, like Monte Carlo, there's several things that you can do in the, for instance, in the sensitivity analysis. One of the things that you can do is that, for instance, you work with probabilistic approach. So I went over that part really quickly, but indeed you can set, let's say, your sensitivity analysis in a way that it almost mimics a Monte Carlo. It's not exactly a Monte Carlo if you look at the technical perspective, but lots of the functionality that you the parameters and their interrespective correlation, to a large extent, we can help you with that. And it would require a bit of a technical session to explain you that in more detail. But the short version of the story is that, yes, we can do that. And especially in the sensitivity analysis, we can help you with that. So if you're interested, I invite you to reach out to us, Amir.
Raghu Ramaswamy has asked, in the sharing, the file depth optimization, does Headwind empirically checked based on mobilized soil concrete friction capacity, since Fluxys does not guarantee file length estimation from numerical analysis?
Good question. So the pile length optimization that I shared in the second case study, what we've done there is to do a static pile load test, and we checked that with the, let's say, with the information that we found from the pile load test. So that specific test that gave us information about the soil conditions. So I would have to double check if we, apart from that, also checked the soil concrete friction capacity. It's a technical question, but I could check it for you. But we checked it in a way, and one of the advantages from Daarwin is that ultimately you arrive at the conclusion that is backed by reality, and that is backed by parameters that you know exist in reality. So even though Fluxys itself may not guarantee the pile length estimation, because of the sense check that we have with the situation on the site and the soil condition on the site, we are able to optimize it in a way that you are much more in control and have much more control over the real life conditions, and therefore also the design that you propose for those for that situation as well. If you want to know that in more detail, we can always jump on a call and discuss it with our geotechnical experts.
So he's also having another question. What was options being used considered for tunneling in Daarwin?
Yeah, that's a good question. So again, we didn't cover that today, and I won't go in too much detail of that today either. I will look if I can find one thing for you. I will go back. I'll show briefly 2 slides for you. In the first place, why is it a problem? Well, similar to, let's say, the construction industry, tunneling projects, they also experience geotechnical difficulties, either cost overruns or schedule overruns. And that poses a challenge, right? Just like we see
Yes.
in our construction industry. Now, what we develop is a tool where we do a few things. What we do is we predict the TBM advance rate. We do that in real time. Then we detect if there's any geotechnical anomalies, and we assist the TBM pilots to optimize the excavation phase. So we deliver information not only to, let's say, the designing team, but also the operating team from usually the contractor's perspective. And all of that is centralized to understand more information about the TBM and the specific ground information condition, or the ground condition, for future projects. So this is a really high-level summary that I would give you. If it's one of our newer developments, so if you're interested in this, I also invite you to send us an email or to book a meeting with us to know more about this in detail.
So,
good.
Next question is from Mehran. He has mentioned in your first successful project, you said that during excavation, you discovered that the density of the soil was better than expected.
Yeah.
Where did you get this information from? Did you conduct any field test or not?
Yeah, exactly. So this is typically something that you can do, right? So it depends a bit on the setup that you have in your project. And what I mean by that is the setup that engineers, contractors, and asset owners work together. Sometimes they, and that was the case in HS2, they work very closely together. There was a lot of cooperation. So what we could do was that during the first excavation phases, we could indeed test the soil conditions. So we got that indeed from, let's say, a field test. We saw that in concrete results. There was, I don't know if you remember that the picture that I showed you during the excavation phase. You can analyze that data. You can either do a soil test or you can do another type of test. But yeah, in this case, a soil test was taken. And once you have that information, well, then you can use it to optimize the rest of your design. So we could basically conclude, okay, in the first 1 or 2 phases, we see a certain pattern. Then we know that for the next 6, 7, 8 phases, we're also going to expect this behavior. And therefore, thanks to the help of the Daarwin BackAnalysis, we are able to optimize this in a more optimal construction method that allowed us to conclude, okay, one of those temporary props is not necessary to be placed because the soil conditions are better. So yeah, in this case, that's one of the techniques that we used. Indeed, early on in the excavation, doing extra tests and then getting that information to improve your design along the way. Great. I also see more compliments. That's always nice to hear.
Yes.
Thank you for that
Thanks,
feedback.
Okay, Rahul has mentioned, I would like to know the criteria adopted for arriving at optimized model, for example, factor of safety, probability as per the codal provisions.
The criteria adopted at arriving at optimized model. I'm not sure if I truly get the question in detail. I'm not sure if you would want to specify that in more detail, Rahul. Sorry if I don't completely understand your question.
Maybe he is asking like how we are getting any results like factor of safety. Is it based on any codal provision or what?
So for this question, I think I would have to rely on even a bit more geotechnical expertise. I have a background in the geotechnical industry, but for this one, I will have to rely on one of our geotechnical experts. So this question, what I can do is I'll send you the information afterwards, Raul, and discuss it quickly with our experts, and then get back to you.
Yes.
Great. Then I think.
Any other questions? Yeah, Maran has mentioned who is responsible for the safety of that project. Optimizing the structures will probably reduce the safety factors of the entire project. Is Daarwin responsible for this?
Yes, a good question. In a short answer, no, Daarwin is not necessarily responsible for to guarantee your design needs to be X or needs to be Y. What we do is we provide the tools for people involved in the process, whether that's a designer or a contractor, to, based on the data available, draw better conclusions. So you can see us as a software provider, an intelligence provider that helps you as a individual or as a company to better assess the situation and better understand the situation. So we base the analyses on the data that is available in the project, and in that sense, it works similar to any software that you would use on a project. If, for instance, there's a delay on your project, you cannot go back to Pluxis and say, hey, actually, our model was different than anticipated. So that is similar in the way that Daarwin works. We provide you the tools to optimize your structure. And ultimately, what we want to do is not necessarily draw conclusions for the designer or for the engineer. What we want to do is speed up the entire process that usually an engineer or designer is involved with, that we can optimize and automate, and arrive at the point where the geotechnical expertise is needed for that user, to be able to use that expertise on those challenges and those questions that are the most relevant. So that's really what we do. We help you, as whether you're again designer, engineer, contractor, asset owner, that you need to assess the situation better. And that's how Daarwin is set up. And that's why Daarwin in itself is not responsible for, let's say, a certain design outcome that you decide to use on your project. We only give you the tools to better assess the situation.
Yeah, definitely. Thanks for that.
Great.
Yeah, another question came from Hari Parimal. Great. What are the standards and are utilized by the softwares? And kindly elaborate how you calculate the carbon dioxide emission reduction. Thank you for your valuable time and presentation. The case study is greatly appreciated. Thank you, Hari very much.
Yeah, so there's basically two parts in there. I would like to highlight both of them. With standards, I assume you also refer to, let's say, the IT standards and software standards. Maybe good to briefly mention. I quickly said something about that, but we as Daarwin and as SAALG Geomechanics, we provide the software and the data that you use in your projects, in your entire Daarwin environment. That is yours and it stays yours, and we believe that that is the way that it should be. So we don't even use your data to optimize our algorithms, to train our data, to test anything. It is yours and it will stay yours for the entirety. So that is one part that I would like to mention. Also, for instance, all the employees, they have signed an NDA, so we don't have access to your data. You as a client and as a user have access to that data, but we don't, unless there's a very specific situation that you say, actually, I could use some support on this question, or I could use I have some question about how to do this. Then in that case, we can decide who needs to jump on your project and who needs to help you. But that's only a very specific case. Now, then the question about the CO2 emissions. In many industries, it's becoming a more relevant topic, obviously. How we calculate it, that is actually that we didn't calculate it ourselves. This is how our clients calculated it themselves. In the specific case that I showed you about HS2, that was because as I said, one of the temporary props between those walls was not needed in the construction anymore. And what that does is that all of that material that you use for that prop is simply not needed because they are constructed really for each project specifically. So only a relative detail in between brackets that you could expect there, or that I showed you right there, can have really significant savings in terms of your carbon footprint. So all of that metal that was not needed to produce can then be used for something else. There's also other subsequent effects that you could have. For instance, the number of times that I don't know, heavy equipment needs to be deployed, or that you need to transfer it from and to the site. Those are other types of calculations that you could do. But in this case, that 440 ton CO2 equivalent was really directly related to the material use and some minor construction activities.
Yeah.
Good. I see that we are at the end of our time, so I think we can close the session for now.
Yes.
From my side.
And stay tuned for our next webinar that we will be planning for a different topic.
Perfect. Thank you. Thank you all for joining once again, and I look forward to staying in touch with all of you. Take care.